Hello and welcome to this video tutorial where I'm going to show you how you can create your own API using Node.js, Express, MongoDB, Atlas, and of course some other tools like Postman and WebStorm. We might also use the Mongoose object data modeling library available on NPM. So I want to try get this all done in under 20 minutes, so with no further ado, let's get started with what we need to do. So first of all, you have to have Node.js installed. Well, it doesn't really matter what version you have installed. It could be version 12.16.3 or version 14. It doesn't really matter. Both of those will work just fine. Even version 10 will work just fine. We're also going to use Express, which is a minimalistic web framework for Node.js. This is where we're going to handle our HTTP requests, create our routes, and handle those routes, give them access to the controllers that we're going to create, going to handle some interaction with the database. Next up is MongoDB Atlas, which is a cloud database solution. So we're going to use this instead of creating our own instance of MongoDB because it's quite safe and it's pretty much what you're probably going to be using in real case scenario, pretty much. And so we can go to the next thing, which is Mongoose, and Mongoose is a very nice library that allows you to interact with the MongoDB database in many ways and forms without actually having to worry about a lot of things that would otherwise you would have to do so. So with this small boilerplate, you can essentially get started with interacting with the database, and this is exactly what we are going to use for our API. We're also going to use Postman, which is a tool for API development. So this way we will be able to test our API endpoints and see what results it returns to us, whether or not some interactions are made in the database. So we can all do that using Postman. And this is how Postman looks like. So here's an example. So this is how Postman loads up, and this is how the user interface looks like. So I'll cover it when the time comes to test our first API endpoint. So you shouldn't worry really much about that. Just go download Postman and we can go ahead and start writing the code. Now, one final bit of software is WebStorm, which is a smart IDE developed by JetBrains. Now, if you don't want to use that, there's a free 30-day trial. You can use it if you want to follow exactly the code editor I use, well, the idea I use in this tutorial. But if you don't want to do so, feel free to use your own code editor. There's really not much of a difference. This is just something I'm very used to, pretty much. So, with no further ado, let's jump into WebStorm right here. And the first thing that we're going to do is essentially create a new file called server.js. So within the server.js, we're going to include the bootstrap code that will pretty much start the Express server that will be hosting all the routes and all our endpoints and the respective actions and interactions with our database. But before we move to do that, it's very important to actually create a package JSON file, and we can do that easily by opening the terminal. Instead of adding it manually, we're going to type npm init. You can choose just the name I've chosen here. You can name however you want your project folder. The version is fine. Description, we don't need that. Now the entry point is going to be server.js. If by default it doesn't say server.js, it says index.js. So make sure to have the name of the bootstrap file inside the entry point. So for our case, it's server.js. Test command, we don't need that. Not create repository. So what I'm going to do is create a repository later, and you don't have to follow the same steps to create a repository. It's just I will make one so that you can use the code after you watch this tutorial, or as you're watching this tutorial, and I will make it available by the time I finish with this video. So keywords, author, license, we don't care about that. Yes. And we have created our package.json. So this is how it looks like. We have the main script that's going to be running, which is server.js. And the very next step we're going to take is install Express. So let's go down here and type npm install -- save Express. So this will install the library, the Express library, and it will add it to the dependencies of the project. So next time somebody downloads the project and runs the npm install command, it's going to install all the dependencies, all the libraries that are used by this API. So seems like we've installed it. We can see a node modules folder right here. And if we go to server, what we're going to do is instantiate Express by typing const express require Express. So we've imported Express, and now we're going to be instantiating an Express function called app. So this is how we can do that. So any Express functions will be accessed via app.something. So app.get, for example. We also need to add a handler, a body parser. So instead of downloading a separate body parser library, Express has already that built in, so they can pass JSON format requests, and we can easily do that by typing app.use, and within here we're going to type express.json, and it should work. Now, as you can see, I might be getting unresolved function. This is because I pretty much haven't included the libraries into my project inside the WebStorm. So I can easily do that. So if you're using WebStorm, you choose JavaScript, go to libraries, and here you have to enable types Express. If you don't have it, you simply click download and you type Express, Express, and you should find it right here. So that's if you're using the same ID as I'm using. So let's apply that. There we go. Now we can see all the methods used by Express are available to us to use, view, and so on and so forth. So we're almost done with setting up the basic core API of how it should pretty much work, but we're not going to use this version. We're going to make it even better. We're going to abide by the model root controller principle. So we're going to have 3 separate folders taking care of 3 separate things. I'm going to explain of this concept in just a bit as soon as we finish with the basic setup. You can be sure that the API actually runs and works on a specific port. So in order to do that, we're going to just finalize by creating a random or just a very basic endpoint, a get HTTP request endpoint, something like hello. And within here, we're going to pass an arrow function with 2 acceptable parameters, the request and the response. And we can use res.status to define the status of the response. For example, 200 is the HTTP code for OK, which means that the query is successful. And then we type send, we type JSON, and we can have a message inside here, something like message hello world. So this is how a basic get request handler looks like. Now we're going to incorporate that into routes and controllers. Later on, we're going to break it down into specific bits and pieces that will make the entire API quite dynamic and take it into a higher level based on 3 different components, which is routes, models, and controllers. Right, so the final bit here is to actually run the instance once the server.js file is run, and we can do that by typing app.listen, and we can put the port number as the first argument. So the port number is 5000 by default. Well, it's not default, it's just Express rounds on 5000 as per convention, but you can use any port, any available port that you want in this case. And we also gonna want to type a small message, maybe callback function, something like this, which is gonna console log the actual location of the API, well, the link to access the API, which in this case is HTTP localhost at port 5000. So if we run node server.js here, it prints it out here, the actual link where the API is hosted. Now just to make it a bit more obvious, we can say API running at that, and let's rerun node, and as you can see, API is running at this location. Now, as I've told you before, we're going to be using Postman for API development. So this means essentially what we're going to do is, let me just delete that. So once you open Postman and you get to this page, you can press the plus button here, and inside the request URL, you're just going to copy paste the request URL you see right here. So we're going to put a get request. Don't forget to select get request here, although it's by default. Sometimes you may have accidentally selected a different HTTP request method, for example post, and in this case it's not going to work, but you have to select the correct one, which you have defined right here. So we have defined a get request. I'm going to send a get request. Now the endpoint is /hello, so we're going to type /hello, and we're going to send the request. We should get a message back, and there we go. We got a message, hello world, return back to us as a JSON object. Alright, now that we are sure that our API is working, well, our basic implementation of the API is working, the next thing to do is actually explain the principle behind model root controller. Model root controller is a principle that you are dividing your entire API into 3 core components. First is, well, in no particular order actually, just it's easier to pronounce, MRC, model root controller. Model is actually a blueprint that you use to interact with the database. So it could be, for example, tasks. So tasks could be a blueprint that accepts specific attributes such as title, description, or something like that. And then you can use that to create documents for the specific collection for MongoDB, or you can actually delete some collections and so on and so forth. So it allows you to easily interact with the database using Mongoose. But we haven't installed Mongoose yet, and the model is going to be towards the last things that we're going to be doing in this video tutorial. Now the next thing is routes, and this is what we're going to be doing next. Routes is where you define essentially the HTTP requests, for example, a GET request or a POST request. So you set up the endpoints in the routes folder. This is where you will create all the specific routes, all the specific endpoints for that particular endpoint or model. For example, if you have tasks, you might want to type something like HTTP localhost 5000/API/tasks/get_task, and here put an ID. So tasks would be a model name that we would create later, but this is just a convention. You don't have to abide by it, but in this tutorial we're going to use this convention, and I think it's a very good habit to pick up by making your API a bit more organized and understandable by other people, including yourself, of course. So what we wrote here, app.get hello, we're going to write something similar in the routes folder. And now each route that we define, for example, hello, instead of writing the actual function here with the response or the request handler, what we're going to do is use controllers, which is the C in the MRC pattern. So we're going to use controller to take care of any sort of handling of the request. For example, interaction with the database, or getting back results, printing a message, or sending a message. But most of the time it's just an interaction with the database, which gives you back value or creates a new resource, it creates a new document or something like that, and it prints back the value or an error message or a success message or something like that. So this is what the controller is going to be doing. So the core logic behind each API request is going to be handled by the controller. The route is going to exactly pinpoint which controller to be called, which method of the controller to be called, as well as which endpoint it belongs to, for example, tasks/getTask/to, and the model is responsible for defining the actual database blueprint that you want to use for specific collections. So I hope the MRC pattern is quite understandable, and as said, the next thing that we're going to do is routes. So we're going to do that by, let's just remove this here and create a new directory called routes. So inside the routes, we're going to create another file called, for example, tasks. So in this case, we're going to be creating tasks and deleting tasks and so on and so forth. So this creation, deletion, reading of a task is called the CRUD principle. Well, it's not really a principle, I call it a principle, but it's pretty much, CRUD is just CRUD. It's an acronym. It stands for create, read, update, and delete. And I'm going to show you exactly what I mean by that. So let's just create the tasks file right here. And we also going to need to define the Express. Well, we're going to need to import Express in this file as well. Even though we have it defined in server.js, also has to import Express. So I'm going to type const express require express, and we're going to use a specific method available in Express called router. So we're going to do the router initialization, and this can be done by typing const router equals express.router as a function. So this variable that we've just created, well, this constant that we just created, is going to allow us to manage different routes, different endpoints for this specific root category, which is tasks. So for example, you could have tasks, you could have users and other group categories or router categories, but in this case we're just going to keep it simple. We're going to have one router category, which is going to be tasks, and we're going to use router in here, just like this. Now, before I start defining things, I want to just talk a bit more about the CRUD. What is CRUD or CRUD? You can pronounce it however you want. So CRUD is an acronym. It's create, read, update, and delete. So the entire basis of this principle is that you can do 4 things, or essentially an API should be doing 4 things, 4 particular things for every single router category that has to do with specific database interaction. So for example, with tasks, we can create a task. So we can create task, we can read the task, and by read, it means that we can actually fetch a task from the database and present it in a JSON format as a GET request or something like that. Update a task and delete a task. So that would enable you to update a specific task or delete it altogether from the database. So there's not much more to it. So this is pretty much CRUD, and just to make a clarification in regards to CRUD, we are going to use we're going to use post request for create. We're going to use get request for read. For update, we're going to use something called patch, which is also valid HTTP request, because you might have heard of get and post mostly, but there's also update, delete, put, and there's many more. But we're going to use these 4. So post, get, patch, and delete is also called delete. So it's quite easy. Alright, now in here we used get. So let's copy this, or actually let's cut it out from here, and let's put it under here. Now we need to do a few changes. Instead of using app.get, because we haven't defined an app here, we don't have to do so. We have router to do that for us. We're going to change app to router. And here we're going to do the following thing. We're going to get rid of the actual handler, the request and response handler, and leave it empty for the time being. As you can see, this should be actually a post request, so I'm going to remove get as well. I'm going to name it post, and it's going to be handling any calls with any HTTP post requests at this specific endpoint. So if we go back to Postman here, we should change that to post before we do anything. It should still be hello, but it's now a post request. So if you keep it at get, it's actually going to either time out or give you an error. Now, if you notice, you can pass 2 parameters at least in this post method. So the first parameter takes actually the path as an argument. So we have defined the path, which is this bit right here. And we also have to define the action. So the action could be rec, res, and something here, which is a handler. But what we're going to do is now get into controllers. So we're going to create a new folder called controllers. And we're going to create a new file with the same name as the one that we created in the roots folder. So we're going to name it tasks as well. So this should have the exact same name, just to keep up with the convention. And it's easier to understand which controller is linked to which router just by keeping the same name. Now for controllers, we don't actually have to import Express or anything like that, because it's simple functions. So it's going to be just simple functions that we are going to export and then import them here and access them with a single variable name. Alright, so let's break this down bit by bit. We have the post request here, and what we can do is create a new function. I'm going to be using an arrow function here again. So I'm going to name it const create post. It will have rec and res as its parameters. And what we can do is simply send a message that maybe a node has been created. So we can type res.status 200.json and type message task created. Actually, we can rename that to create task. I think it should be a bit more semantic this way. Instead of create post, it's tasks that we're going to be creating. So create task, and we have this function here available, but it's not currently available to be imported inside routes, because what we need to do is the final bit for the controllers, which is module.exports equals, and it can be an object that takes a series of functions as their attributes. Now, the reason why I'm not just assigning the value of exports to the function as it is because we are going to create 3 more functions for get, patch, and delete, and this means that we have to export them all together at the same time. So this is why I'm actually making an object, and we're going to pass the rest of the functions as attributes inside here. Now that we've done that, we can go back to roots, and we can go here and type const tasks controller equals require, and now we're going to type double dot to go 1 directory down. So since we are in roots, we are in this folder, we have to go 1 directory down to the parent directory, access controllers, and within the controls folder we need to access tasks. Right, good. So this now allows us to use the create task function that we just created. And in order to do that, we type task controller dot create task. And this is pretty much it. So let's try and see if it all comes together and if it works. Let's open up Postman and go here and type send. Now don't forget that you should have changed this request to post and shouldn't be get. Otherwise you're going to either time out or get an error. So let's type send, and it says cannot pass hello. Now why is this? That's because we actually haven't linked our routes to our server.js file, and this is very important. So in order to do that, we have to do one final bit of work. Go back to server.js and type app.use/API/tasks, and in the end we're going to pass the actual route that we've created. Now we haven't defined it here, we just have to import it. So we're going to type const tasks routes, and that's going to be a require routes tasks, and we can use this imported file now as the second argument that we're going to pass here, task routes. So what this bit of code does is it actually defines the pre-endpoint part. Now this means instead of typing /hello, what we do is type /API/tasks, and then if you look for routes in here, and we have the hello route, and then we would type hello. So this as easy as it gets. Now of course you don't have to type /API/tasks, it could be anything you want here, it's entirely up to you, but it's very good convention to type /API/the actual endpoint category, or root category in this case, and then inside the root category you have specific routes belonging to specific controllers. So now let's try again, type send, and now we get again the same error. That's because we haven't refreshed our instance of the API. Now instead of typing every time node server.js to rerun the API with the new changes, instead of doing that, what we can do is install a library, an npm library called NodeMon. So it's short for Node Monitor. So it's going to be monitoring for any changes in our files. It will be updating the instance again, or rather rerunning the same instance. So what we can do is type npm install --save dev and type the name of the library called NodeMon. Let's install that. And I think it would be also a good idea to just install that globally so that you can use that anywhere in any project. So I'll just install that globally. But I'm including it within this specific project just for the sake that you might need to use it and you don't want to install it globally. But I've installed it globally as well and should be fine now. Instead of typing node server.js, we're going to type NodeMon server.js. And we get an error. That's because we haven't actually exported the router. Just like I've said before, we have to export all the variables and functions of the specific file. So in this case, when you do module.exports equals router. There we go. And now this should work. Now let's see, by pressing Control Save, it should restart. Okay, and we're getting the error again is because we should probably, it's looking for a node module. So there's a common mistake that is happening. So if you're not defining /something, it's going to be looking in the node modules. Since it doesn't exist in node modules, but exists within our local directory, this is why we have to use // or .. to specify that this file is actually a local module and it's not an npm module. So if we click save now, it should be running, and there we go, it runs just fine. Let's go to Postman again and click on send. And there we go, we have message sent called task created. Nice. So what we need to do now is instead of creating any new things inside here for now, what we can do is just simply go to roots and create this task and create the HTTP requests for the specific tasks that we need before moving on to the database implementation, where we will be able to query the database and create a new task, delete a task, update a task, or even read a task pretty much. So for now, let's just create those endpoints and create the appropriate controllers that will print a message just to test out whether or not these specific endpoints work with their specific controllers. So let's type router.get /get task /id. Now, this is quite important. If you use :id, this means you can type something like this. You can go tasks get task /to, and you can use this as a parameter and query the database using pretty much this parameter. Parameter will have a name of ID, and I will show you exactly how we can use that once we implement the controller for this specific endpoint. So for now, let's leave that there. Let's type task controller.get task, and now keep in mind it says unresolved variable task. That's because we haven't created the function, anonymous function, yet inside the task controller. We're gonna do that later. Let's just finish writing this up. So router.get update task /id. I'm gonna have .update task here as well. And finally, we need one more router. Oh, whoops! Instead of get, this should be patch. And now finally, we need to create a delete HTTP request handler, and it's gonna be delete task /id. And of course, we're gonna use task controller .delete task. Alright, before I forget, let's change this hello to create task. This should be pretty much what we need to do. We shouldn't be having to change anything in the roots anymore, in the roots folder in the tasks file. Our entire concern now is task controllers and the tasks model, which we're going to cover as soon as we implement the basic handlers for those specific routes that we've just created. So let's create const get task rec res like that, and I'm going to show you how we can actually get the parameter from the URL that we've entered right here. So to do that, what we have to do is essentially access that via rec.params.id. So it will look into URL parameters and look for the ID parameter which we have defined in the roots file. So this ID. So this is where the ID comes from. So any number or any value, any number or any value coming here is going to be considered the ID. So let's write up this correctly. res.status 200 JSON message, and we're going to, or actually task ID, and we're going to return the actual task ID, which is recparams.id. And let me just do that. Cool. We're going to include that in the get task, in the module exports. We're going to include get task in the module exports, and we're going to copy paste this twice. We're going to have one for update task, and one for delete task. And we're also going to add them to the actual object, update task, delete task. Let's save, refresh, and let's try doing get task. So don't forget to change to the appropriate HTTP request type. So this one is get, there we go, we got 2. So if we change that to 1, it's going to be 1. Of course, we can also accept text, so it can be test here. And this is where you will have to use specific input validation provisions. So you'll have to create some input validation. We're not going to do any of that. There's no security, there's no input validation, and you should never trust what the client sends. You should double check on the server side whether or not that input is valid. But for the sake of this video tutorial, we're just going to implement the basic structure and the basic API and integration with the database, just so you have an idea, and the rest of the validation and helpers and whatever else you want to implement is going to be up to you depending on what you need to do. So we have get task working. Let's try patch for update task here. Let's see if we get a message. Yep, we get the task ID 2 again. And finally delete task 2. There we go, it all works. Alright, nice. So far so good. We have done the routes, we have set up the server bootstrap, and we also created the controllers for the specific routes endpoints. And the last thing to do is actually create a database and perform the integration of the API with the actual database. Now, before we do any installation and do any integration on the API side, it's time to actually get an account or create an account and an instance of MongoDB. So I have an account already. So you'll be greeted with this page right here. It will ask you to create a cluster. You can click on the build a cluster button and you can choose the free cluster tier right over here. Now you can choose either one of the available recommended region options. In my case, I'll choose Ireland since I live in the UK and Ireland is pretty much the closest location to me. You don't have to do any specific setup for the rest of the settings like cluster tier or additional settings. You don't have to choose anything here. Just go straight to the green button here, create cluster, click on it, and should be creating the cluster for you. Once the cluster has finished building, what we're going to do is set up our security access, add our IP to the whitelist, and then connect that to our API. Well, once the API has established connection to the database, we will then implement Mongoose, install Mongoose library and implement our first model and perform database interactions in our current controllers, because right now our current controllers are just dummies. They just give back either message in text or the actual parameter ID. Right, so our cluster has been built, it's up and running, and what we need to do in this case is go to the left hand side under security, there's database and network access. Let's go to the network access first. So this is my IP address. I've hidden it for obvious reasons, but it shows that it automatically fetches the IP you have logged in with and it adds it to the whitelist. So if you want to access the database through other IP addresses, then unfortunately you can't do that unless you add it to the whitelist of IPs. So to do that, you will go to the right hand side, click on add IP and add your IP. Or something that's more of a security risk is you can allow access from anywhere. This means anyone with your credentials will be able to access the actual database. But I wouldn't recommend that. I mean, this is just fine, so you can use your IP address and test it locally and add anybody else's who might want to be testing the database to the whitelist of IP addresses. So let's go to the database access, and here you can see that there's a user with authentication method and has read-write any database access role. So if you click edit, you can also change that person to be an Atlas admin, but you don't really have to do that because just by having read and write privileges to any database, that should be sufficient. However, you might not know the password that has been generated for you, and in this case you have to click edit password. So I'm going to auto-generate a password here, click on show, and this is the password that I'm going to use. So I'm going to copy that, I'm going to paste it somewhere here as a comment. Let's go to the server, I'm going to paste it here, pass, and the user is Nick. So the final thing is to go back to the clusters and type connect and choose connect to your application. Once you do that, you should select the driver Node.js. It should be by default, but if not, that's absolutely fine. And you will need just the connection string. You don't need anything else. Now the password is the password that we've generated just earlier, so you can use that password inside here and replace this string. Alright, let's copy that. Let's go back to the editor and let's add that as comment here, just not to forget what's the connection link. So this is essentially the connection link. Right, I'm gonna cancel the running instance and we're going to go ahead with installing the Mongoose library. Now, as I said before, Mongoose is an object model library for MongoDB. So we're going to type npm install --save mongoose. And we're going to open Mongoose ODM here and take a look at how a model would look like. So essentially you need to import Mongoose, establish a connection, and then create the model. Now we're going to do that step by step, and the most important thing is to establish the connection to the database first. And we're going to do that inside server.js, and this is why we've copied all this information here. Before we do that, we have to actually import it, as said before. So we're going to type const mongoose require mongoose. So we have mongoose imported right here, and before we actually start listening, what we want to do is establish a connection to the database. Now this is how we're going to do that. We're going to type mongoose.connect, and this takes a few parameters. So it takes a URI string as an argument here, which is the URI string we copied earlier. So we're going to put that here. I think we can remove test. Test is the name of the collection, but in our case we can just use tasks like that. So we're going to be connecting to the tasks collection on our MongoDB database instead of the test one. Now the next parameter is options. So inside options, it's an object which will take a few attributes with specific values. So we need to type use new URL parser, put it to true. Now the reason we need to do that and whatever else we type here is because some things are deprecated, some things are recommended for when using MongoDB. It might give you some warnings, such as crack on with defining those attributes and give them the default values that are recommended. So that should be true as well. And use find and modify should be false. Use create index should be true. It would be wise to allow the API to run only if the connection to the database has been successful. Now, as you can see, I almost forgot to replace the password here with the actual password. So this is what you have to do. Don't forget to replace your password, otherwise it's not gonna connect. We need to allow, well, we need to make it so the API runs only if the connection to the database is successful. And to do that, we're gonna use a promise. So mongoose.connect is actually a promise all by itself. We're gonna type then and an anonymous arrow function inside here. And of course, we're gonna also use catch with an error and print out to the console, to the API console, the nature of the error. For example, if the database is down, it will not start the API will not work, and will tell you that it doesn't work in the console. So you're going to type console.log error. In case it connects successfully, what we need to do is actually create an instance, and we have already done that. It's right here below. So we're going to cut this, put it inside here, and this instance will run once the connection to the database has been established successfully. Let's go ahead and run nodemon server.js, and as you can see, it has successfully connected. Now, let's create the long-awaited model. To do that, we're going to create a new directory called models. Inside models, we're going to create tasks file, JavaScript file. As you can see, we follow the same naming convention across all three components of the MRC pattern. For the tasks model, what we're going to do is actually require Mongoose here as well, because we want to use something called schema, well, a blueprint of how the actual collection is going to look like. So const mongoose require mongoose. And to define a schema that's going to be used for the specific modal, we can just type const tasks schema, or this double S here, I don't like that, task schema, mongoose.schema. And just because we're going to create a new instance of that, it's going to be a new instance of the schema class. So we're going to type new mongoose schema, and we're going to pass in an object. Now we need to define exactly what sort of schema we want this collection to have. So we're going to need a title for the task. So we're going to type title, which is going to be of type string, and it's going to be required whenever we create a new entry using this schema. So required is true again. Of course, there's some things like, for example, min length. You can define the minimum length of the title or the maximum length, but we're not going to do that. There's the documentation. I have included all links in the description below in case you need to learn all the crucial bits and pieces of the specific implementation. So let's go down to adding assignee. So that's the person to whom you assign the task. So let's call that like that. It should be of type string, required true. And maybe also have, maybe if you complete the task, have the status. So it should be type string, required true as well. So you have a status. Actually, let me try and say completed. So if it's true, the task is completed. If it's false, it's not completed. And let's also have default value to be false. So whenever we create a new entry using this schema, the default value for the task will of course be not completed. Alright, cool. So this is our schema. And now of course we don't have to forget to actually export that schema by typing module exports task schema. And there we go. And now all we need to do is just update the tasks to be able to interact with the database and the model that we created. Let's go ahead and jump straight into tasks.js for the controllers. And on the top here, we're going to do is const task schema equals require. And let's import the actual schema, well, the model that we have. It's one directory below, inside models folder, inside tasks. And now, let's see, if we go to the create task and type task schema dot, we can use a lot of things. We can get the ID, we can clone. Now, if we go back to the website right here, we can see an example of how we can create a new entry. So let's copy that. Let's go back here. Let's put it down. And we're going to have to remove this. We don't need that modal. We use the schema already. So to create a new instance, instead of saying kitty, for example, what we can do is look for the body of the request, where we'll be expecting to get the values we see here: title, assignee, and completed. Now, what's the body values? If you go back to the Postman and click body, and then select raw, and in the drop-down menu, you can select JSON. Here's how it's going to look like. So this is what we're going to be sending to the API to process. So this is the body of the entire request. Here, we would type the title, new task. We would put, well, what else do we have here? We put the assignee, nick, and we also would include completed value, which is Boolean, and in this case would be false. But we don't have to necessarily define that because it's automatically defined in here. So by default, we can omit that bit and just send the title in the assignee, and then the API, or rather Mongoose, will take care of setting the value of completed to by default to false. So all we need to do is just in the body of our request send these two attributes with their specific values. Let's go into controllers, and here we're going to type const task is new task schema, and inside here we're going to pass the values that we get from the body. And in order to do that, we first have, of course, to include these two attributes. Title should be the rec body.title, and the same thing is going to happen for assignee, rec body assignee. There we go. So this should create a new task. And now to save that onto the database, we would type task.save, then console log task created. Now what we can also do inside here is also send a JSON message in case the task has been created successfully. So in order to do that, instead of typing console log or just console log, what we can do is output that in the console, but also send an appropriate JSON message back to the requester. Let's just finish here saying task created. So this should print in console, and this should send JSON to requester. Now, what if the actual request fails? Well, in this case, we can also make use of .catch tag as we used before inside server.js. So we caught an exception. We can do the exact same thing. Let's type error, and this should actually send them a message called with the value of the error. And instead of status 200, we're going to say 500, which is internal server error. Print out the message of the error into the JSON. So what we can do is go to Postman, change this to post, change that to create task, type the names here that I already typed that, and then click send. Oh, and of course we get an error because I forgot to mention that we're not using the schema as per se. We actually have to convert that into a model. So to do that, at the end here, module exports should be mongoose.model and should take a name as a parameter task, for example, and the actual schema as the second argument. So this should work now. So if we refresh, save that, send again, task created. There we go. Let's go to our database and let's check out whether or not we have the entries. To do that, you go to the collections button and should be receiving the collection. So we go to tasks, and there we go. We have our task created. So we've just implemented the create part of the controller integration, well, rather API integration with a database. Next thing is to get the task, well, read the task based on the actual ID, and also either update it or delete it. And we're going to do that just right now. Let's go to the tasks, and in the get task function, what we're going to do is access task schema. We're going to type .find, and here we're going to pass the ID that we get, rec params ID. So what will be happening now is essentially we will go to Postman, update this URL, and this value here will be checked against the database, and if the match exists with that specific ID, it should return that object with that information. To do that, all we're gonna do is just slightly change the request handler here. So what it needs to do is it should match this condition. So if the underscore ID, now why underscore ID and not ID? Well, that's because we have underscore ID right here. It should be the object ID. So if we copy this object ID, this is the ID of the post. It's not like 1, 2, 3 incremented, because, well, you can do that if you want to, but MongoDB automatically generates ID whenever you make a new entry. It's a random ID number, so it should be working just fine. You don't have to do any extra legwork here. So we copy this ID. Let me see if I copied that correctly. Yeah, there we go. So let's put that down and go here. So it should be looking for the ID parameter. It should get this ID value and should run a find query for that specific collection and return the results. To return the results, we're going to create a function with error and results as the callback function. And here we need to check whether or not there is an error. So if there's an error, right, we should console log that error into the API environment, well, the terminal here that we're running, as well as maybe send that error message to the front end, meaning Postman, that's what I mean by the front end. So should send the error. Otherwise, if there's no error, then what we need to do is actually send the document object as JSON response to the actual requester, which was done by Postman. So to do that, all we need to do is type res status 200.json and pass the results, which is already an object, so you don't have to wrap it something like that. You don't have to do this because it's already an object that is being returned. Now we can get rid of this and save that. And let's run the query. Let's get the request. Don't forget to change that to get from post. There we go. So we run a get request, it searched for the database, and it found a match. Now if we change that, it doesn't find anything, and we send, it should return, well, it returns an empty result. There we go. But if there's something terribly wrong with the query, it should give you the error right here. So it all works as intended so far, which is quite surprising because sometimes you get errors like I did earlier before. So let's do that again. And there we go, we found that. And we also got the console log to output the error here. So we've done create task, get task. Now we need to update and delete. To update the task, what we're going to do is, again, copy all this code because it's quite reusable. As you can see, it's all pretty much reusable. You don't have to make a lot of changes. So it should be quite easy to get started with it and adapt it on the go. So what we want to do here is change, instead of saying find, we say find one and update. So it should find the matching element and then perform an update. Instead of typing if error or else, we can remove this object. We don't need this. What we're gonna do, actually, let me remove that properly. There we go. Cool. So the second argument, or the second parameter, is gonna be update, and the update will be an object that has another object, well, attribute with an object called set. So this is gonna set the value to whichever new information we have passed. So in this case, what we're going to have is change the title to rec body title. We also change the assignee, if we want to change the assignee, to rec body assignee. And finally, we can also pass another option called new true. If all this runs successfully, what we can do is print out a message inside the console saying everything is successful, and as well as update the user in the front end in the API, send the requester a message, a JSON message saying that update works successfully. So to do that, we're going to assign this to a variable. So we're going to say update task update. So we're going to be actually constant. So we can assign it constant, and we're going to check if the update was successful. So if the update was successful, it should return a JSON message object saying successfully updated. So message successfully updated. But if it's not successful, then we can pretty much say that the update wasn't successful. We can say 500 or 500. There was probably an issue with the database. Maybe the document doesn't exist within the collection, so we can say could not update. So let's save that, and let's go back here, and let's change the task name to update task name, and keep the assignee the same, update task name. Let's change the get request to patch, because patch is the HTTP request appropriate for updating a resource. So go patch, and instead of get task, we're gonna type update task, giving the ID the same. I think the ID is correct. Yeah, it's correct. So let's type that. Click send. Successfully updated. Now, if we refresh, it still says new task for some. I think that's because we have to have an asynchronous call. So to do that, we're going to type async here, and this should be a wait like that. So let's refresh. Let's send. And let's try and see again. There we go. Updated task name. So the issue here was essentially that we've sent an asynchronous request in a synchronous way. So this is important to have here. When updating something, it should be asynchronous request. So we have async entered before the actual parameters for the arrow function, and also have the await tag when we actually do the call to the database to update the database. Alright, cool. And now the delete task should be the same. So we'll kind of have async as well here. And instead of typing find one and delete, what we're going to do is do pretty much something similar. We're going to find one and delete instead of update. So to do that, we're going to type here const task delete equals await task schema dot find one and delete. The condition is here. There we go. And we don't need to do anything else. Just do the same comparison. If task delete, send successfully deleted. Otherwise, could not delete. And remove this bit, last bit over here. Alright, let's save. And let's delete the task. Let's go delete here. Change the endpoint to delete task. Let's send. Successfully deleted. So let's go back to our database. Let's refresh. And there's no queries. So we've deleted that. Alright. So I think this is pretty much it. We've done pretty much a lot of good work. Just to conclude, just to do a recap. So we've created a server bootstrap page here. Sorry, a file page. Where we included the dependencies using Express. Express was the web framework that we used to handle HTTP requests. We also used Mongoose to perform interactions, to connect with the database and perform interactions with the database. We've set up a database cluster, well, a MongoDB cluster for free on MongoDB website. We also created routes, controllers, and modals. This is pretty much it. Thank you very much for watching. If you've enjoyed this content, if you've enjoyed this tutorial, make sure to hit the like and the subscribe button. I'm looking forward to making more of these videos, more of these tutorials, maybe some vlogs and so on and so forth. So I would appreciate if you guys could support me. So this is pretty much all for now. I'm going to make the Git repository available after I upload this video. It should be in the link in the description below by the time this video is uploaded. And thank you very much once again for watching.